So this is the GCSE OCR 21st Century Chemistry High Tier paper, and we are looking at question 8. So diamond and graphite are allotropes of carbon. Models of diamond and graphite are shown in figure 8.1. So we've got diamond and graphite. Graphite can mark paper, but diamond cannot. Explain why. Use ideas about intermolecular forces and bonding in your answer. So first thing we need to realize is that in the question it tells us what we need to talk about. We need to talk about the bonding, the forces, and we need to explain why this happens. Why graphite can mark paper. So in pencils, they're made up of graphite. The bit that you write with is actually graphite. So why is it that it can mark paper but diamond it cannot? Okay, we need to talk about both diamond and graphite, and it's a 3-mark question, so we need to be mentioning 3 different points. So what you need to know about these two structures is that they're both giant covalent structures. The reason we call them giant is because they are made up of lots and lots of carbon atoms. There is no definite number of carbon atoms, okay? It's just a very big number, and obviously it's called covalent structures because they're made up of carbon atoms that are covalently bonded together in each of those. In diamond, each carbon atom is bonded to 4 other carbon atoms. In graphite, each carbon atom is bonded to 3 other carbon atoms. Carbon can actually bond with 4 other things. So in here, there's actually 1 extra electron that is not bonded, so it's free to move around. So for each carbon atom, there's a free electron that is delocalized, which means that it's kind of not associated with 1 carbon atom. It can move around within the structure. And graphite is actually a layered structure, which means we have strong covalent bonds within each layer, within the carbon atoms in each layer, that forms these hexagonal rings, but between the layers there are weak forces, and these forces can easily be overcome. So that's what you need to mention in here. Oh, the last thing I forgot to mention is that an allotrope is basically different forms of the same element, in this case carbon. So both diamond and graphite are made up of just carbon atoms, but they're just arranged and bonded differently, so we call them allotropes. So the first thing you need to mention is that there are weak forces between the layers in graphite, and the second point you need to mention is therefore these layers can easily slide over each other. And the last thing you need to mention is why diamond cannot mark paper, and the reason that is because there is no weak forces here. It's just these strong covalent bonds, and that's all there is. Each carbon atom is bonded to 4 other carbon atoms by strong covalent bonds. So all the carbon atoms in diamond are held together by strong covalent bonds. And that will give you the 3 marks for this question. Part B. Figure 8.2 shows a model of sodium chloride. What type of structure does sodium chloride have? You should include the type of bonding in your answer. And the answer for this is a giant ionic structure. Now, if you just said ionic, that would have given you the mark, but it's actually a giant ionic structure. Again, it's giant because it's made up of lots and lots of these sodium and chloride ions being repeated over and over again in this crystal. And it's ionic as well because sodium has Na plus charge and chloride has a minus charge, and these are oppositely charged ions that are attracted to each other. So we have sodium, we have Cl, that's the Cl, sodium, so it's like repeated units that are kind of repeated over and over again. And the last part, complete the table to explain how graphite and sodium chloride conduct electricity. So graphite can conduct electricity when solid. If you look back at the structure of graphite, remember we said there are free moving electrons, delocalized electrons, so it's not just bound in one place, it can actually move around within the structure, and therefore graphite can conduct electricity even though it's a solid because there are free electrons. For sodium chloride it's actually slightly different because these ions, these charged ions, can conduct electricity but only when they're in a liquid form, so either when sodium chloride is molten or when it's in solution, okay? Because in a solid state these ions are fixed in one place and they can't move about, so they can't conduct electricity. So sodium chloride only conducts electricity when either molten or in solution, so basically dissolved in water, for example. And the particles that are responsible for the conduction of electricity in graphite, remember we said these electrons are responsible for conducting the electricity, so in here it's just electrons. But for sodium chloride, It's actually the ions, these positively charged and negatively charged ions conduct electricity.